Hi, welcome to the video on electron configuration using the periodic table versus the atomic orbital model. The purpose of this video is to compare how both the periodic table and the atomic orbital model can be used to determine electron configuration. So you've already looked at using the atomic orbital model. That's where you're filling up those boxes with the arrows, starting from the bottom to the top. And you started looking at how we can use the periodic table to do that. Now, in determining electron configuration for both of them, we're doing very different things, so it's a good idea to sort of compare them. So here we have a periodic table, and on this side, on the right side, we have the atomic orbital model. If I asked you to determine the electron configuration for an element like, let's say, selenium, which has an atomic number of 34, if you're using the atomic orbital model, assuming that selenium is neutral, you would start at the bottom or the lowest energy orbital, following Affel's principle, and then fill up those 34 electrons from the bottom to the top. And of course, you would use Hund's rule and Pauli exclusion principle as well. But that's what we've looked at. But how do we do that with the periodic table? Is it done in the same way? So what we would want to do is we would first, when given the periodic table, is figure out which block it's in, which block the element is in. Is it S, P, D, F? And what is the N part of the configuration? So selenium, as you can see, is in the P block, right? The P block starts here in group 13 and goes all the way over to group 18. So that chunk here, that square, that's shown in yellow. And so because it's in the P block, I know that's in configuration, or the would be P something. How many electrons in that last p orbital? To determine that, we would count over the number of groups it's in that p block. So it's the fourth group over in the p block. So that's why it's above that group is p4. And then the shell that it's in will correspond to the period or row it's in. So it's in the fourth period or row. So that will be 4p4. This 4 in the front comes from the period or row that it's in. It's in the fourth row. Now, how do we fill in the rest of the configuration? We figure out how to get the N, but what about the rest? So when determining electron configuration from a periodic table, where we actually start is we start with hydrogen. And hydrogen's configuration is 1s1, because it's in the S block, it's in the first one in the S block, and it's in that first period there. So it's 1s1. And then we kind of go all the way to the end of that first row, which leads you to helium, which is 1s2. And then we sort of snake around, okay? So let's take a look at that here. And we'll compare it to how we do the atomic orbital. So again, we figured out what the N configuration is. Let's fill in the rest. We're starting with hydrogen. That's 1s1. And then we go over to helium, which is 1s2. And you can see those 2 electrons have filled into our atomic orbital model. Then I go down to the next period, where lithium is. That corresponds to 2s1. So now we have electrons in the 2s1 in the atomic orbital. And then we go to beryllium, which is 2s2. And we're just going to keep going. 2p1, boron, etc. We're just filling them in. Now you'll notice with the periodic table, we're going across. And as we get to the end, we go down to the next row. So now we're at sodium, and that's 3s1. But in the atomic orbital model, we're filling up. Okay, so that's one difference. Magnesium is 3s2. Aluminum would be our, 3p1. Silicon 3p2, etc. And we're just filling them in as we go across. And notice that the atomic orbitals are filling up at the same time as well. Now we're in this last period here, so we're at potassium, that's 4s1. Calcium is 4s2. And then we're getting to our D block. Now, the thing to remember about the D block is that the electrons in the D block are going to be in the shell that's 1 less in number than the period. So this is the fourth period, but these are the 3Ds. Okay? So this will be 3D1, not 4D1, even though it's in the fourth period. And we keep going as we fill them in. All right. I just want to note here we're ignoring the exceptions like the half fill, completely fill for chromium or copper. We're ignoring that for now just because we're just showing how sort of the electrons filled up compared with the atomic orbital. And we get to the end of that D block, which is 3d10. And now we go right back into the P block. Okay, so gallium is 4p1, germanium is 4p2, arsenic is 4p3, and finally we end with selenium, which is that 4p4. Okay, so major differences here with the periodic table configuration versus atomic orbital. For atomic orbital, we start at the bottom, we fill them up as we go. With the periodic table, you start where hydrogen is, and then you go to the end of the row, and as you're going through each row, you're filling up electrons. Once you get to the end of that period or row, you drop down to the next period and start filling up again, starting with that S block, and then go to the end of the P block, etc. So that's pretty much how this works. It's a little different because you're not going up, you're kind of going snaking around with the periodic table, but you can use either. Hope you found this video helpful. Have a quality day.